Welcome, teachers and educators from around the world to this Lab4U webinar centered around the camera tool and experimenting from home in this particular special period of time and difficulty for everyone. So we will be addressing some of your questions about the camera tool today, and we'll be giving you some tips about how to do experiments with your students at home. So prepare yourself, prepare your materials, everything that you need to join us in the journey of experimenting and figuring out the world through science. So you are very welcome.
Absolutely. Thank you so much, everyone, for joining. We are live on YouTube and we are in this call with so many of you. Thank you so much for joining us today. Very happy. See some known faces there. Thank you so much, Miss Martha, for joining us. Thank you so much. Thank you, David. Thank you, Gaola. I don't know if I'm pronouncing that well. Sorry if I'm not. Thank you, Hector. Thank you, Lisel. Thank you, everyone, for joining us today. We'll be starting very soon.
Thank you. And as a starting point, we would like you to uh, we would like to write in the chat your name and where are you from. What are your expectations for today? So write that in the chat. We will be presenting ourselves in a few moments when we start this webinar. So where are you from? What do you want to see today?
Write in the chat. Let's write in the chat.
Welcome, Martha. A two-dimensional motion lab, it's exactly what we're going to do today. So this is a perfect match.
Yeah, and the experiment we're gonna do today in this webinar was actually inspired by Miss Martha. So
Welcome, David from London. If you are more comfortable in Spanish, we have a parallel webinar series in Spanish, so we can send you the invitation to that also. If you wanna speak a little bit and hear us speaking in Spanish for a bit, that would be awesome.
Yeah, so we actually had the same webinar on Tuesday, but in Spanish. So those who are joining us from Latin America or Spain can check out the Spanish version of this webinar that was on. So every week we're having English and Spanish. This is the English version of it. So welcome also Mok Gaola from South Africa. So we have Sacramento, California, London, South Africa. Oh yeah, David, time difference is always a challenge. We've been testing different times because whenever we have like time different issues, we know that someone is not going to be happy, either the early risers or the ones who enter later. So it's been a bit challenging to match all the time differences. But thanks for the comment. What time is it in London right now, David? I see. It's 9 p.m., right? For some, it's like afternoon. For some, is like noon. So yeah, we're definitely checking on different time zones. But thank you so much, everyone, for joining. Always a pleasure to share with you all. And we're starting in a few seconds now. Starting in a few seconds. Oh, in South Africa is also late. And in California, it's what, 1, 105, 105 right now, right? So those are different time difference. Awesome. So thank you all for joining. It's always a pleasure to be with you all here today. Always excited to share with you all our experience in science education. For today's webinar, make sure you have Lab4Physics downloaded in your devices. So if you don't have Lab4Physics downloaded in your devices, you can download it in Google Play and App Store. Or and for today, for the next 24 hours, we're going to have a special demo account for you all. My colleagues are just going to copy paste in the chat here. If you don't have a premium account, for 24 hours, we're going to give you a demo account here that we're going to paste and copy in the chat. So we're going to copy paste here in the chat the demo account. And we want you all to experiment with us. So we will be needing some materials today. Make sure you have in handing a measuring tape. Where is your measuring tape? Make sure you have handy a measuring tape, a cardboard. If you have a cardboard around, I've got my cardboard here. I've got some cardboard here, like cardboard here. Make sure you have some cardboard with you, a compass or something where you can mark a circle, some scissors, or or not, and a marble or a steel ball or some kind of circular marble or ball. And if you have someone around at home, maybe a helper, a sibling, a colleague, a significant other, if you have someone at home that can experiment with you, that would also be great. So don't forget to download Lab4Physics, uh, and uh, and we will start experimenting soon. Fantastic. Here we go. I've texted here in the chat. Those who don't have a Lab4Physics premium account, we have a 24-hour demo here. In this webinar, it's going to be me and Professor Javier, with whom we learn so much always. And our objective, of course, is to experiment at home using the camera. So we're going to use the camera today. Very briefly, our agenda: we're going to experiment. We're going to learn how to use the camera. And we're going to see the context of the experiment and then end. And let's see. I've been receiving some texts from my colleagues. Professor Javier is having some connection problems. No worry, Javier, we'll wait for you. So why experiment? At Lab4U, we truly believe that the best way to develop 21st century skills, to focusing on skills or STEM skills, we require inquiry and experimentation so that we can help the future of the workforce for tomorrow. We know that all of you are going through some difficult times teaching from home. We know it's not easy, but we want to help you in that, inspiring you with some experiments that can help you in your science classes, either virtually, distance, or in person or hybrid. So what we do? We transform smartphones and tablets into complete science labs. We use the camera, the microphone, the accelerometer, and we transform this into measuring devices. So here's a short demo of some of our tools like Lab4Physics. You can see here students how they're experimenting with their phones, pendulum movement, centripetal acceleration. Here, students are analyzing distance and displacement, and they're graphing it. This is force, mass, and acceleration. Or in chemistry, we also had a chemistry webinar recently where you can calculate the concentration of a solution using the camera of the phone. Where we use computer vision to calculate the concentration, so schools or students don't have to buy an expensive colorimeter. So we've seen users around the world actually experimenting at home, and we're very proud and happy to see different students around the world experimenting. Very proud to see all of them using their devices, sharing their stories and their experiences with different with their teachers. We know some of you have been experimenting with your students, and you're asking your students to send some evidence of their experimentation. That we believe is so important, because we see that siblings are helping students to take pictures. We see parents are more involved, and parents are happy because they're not they're not all the day in a screen, but they're actually doing something with their hands, and they're experimenting. So that makes us really happy when we see students actually using their hands, building, experimenting, etc. We believe in pedagogy. Pedagogy is equally important. Technology is not the end, it's a means to an end. So we combine everything with inquiry-based learning pedagogy, and for us that's important. So let's experiment. If my colleagues can write me in the chat, if Professor Javier is already in, if he was able to solve his internet problem or light problem. If you guys can call him and check out. No, they're saying that Professor Javier is not here. So because we are a team, I'm gonna back up Professor Javier for now until he returns. Fantastic, he's reconnecting. Brilliant. That happens with distance learning and distance and in the virtual environment. It happens all the time. It can happen to us, it can happen to you all when you're teaching. So today, some of the key concepts we're going to work with: parabolic motion, uh, gravity, Galileo's principle of superposition, which Professor Javier is obviously going to explain much better than me, dimensional motion, rotation, other kinds of movement, sports and optimization, trajectories, and equations of motion. And to study these key concepts, we have prepared an interesting experiment for you all. And Javier, why don't you take it from here and inspire us with this experiment?
Can you hear me? Can you hear me okay?
Absolutely.
Cool,
Yes.
cool. Sorry for the delay. We have a power shortage here locally, so hopefully recover very fast. Galileo's principle of superposition is the principle where you can observe two uh, motions in just one complex motion. For example, a parabolic motion can be observed as a falling motion, a one-dimensional falling motion, and one-dimensional movement with constant speed. So both of those movements mixed up in the parabolic motion, and we can observe that we can separate those two directions and analyze them separately with their separate influences, the gravity and no gravity. And the other two-dimensional examples there are things that you could explore with the tool that we will be using today. And if you move those topics to the real world, you have sports optimization of trajectories, and some other historical applications like cannonballs and war that may not be suitable to all environments, but they are more close to sports. So sports is a very, very complex and very good application of two-dimensional motion, and those motions could be really complicated if you add air to the mix in the real world. And we'll be analyzing a real world experiment, so air could be a factor in our experiment today. So the idea for the motivation for us and for our students, if you want to do some experiment like this, is that you have a basketball friend that asks you to for your help. He wants to improve, be more accurate with their 3-point shots. Those are hard to accomplish, and it involves not only the motor skills but also the positional awareness on the field and how the ball will travel to the hoop, because there are several trajectories that could help you to to score 3 points, but there are many more that won't allow you to do that. So the idea is that us, not as sportmen but as a scientist, will study some of those trajectories in order to give some clues to our friend. And we will describe now the experiment so you have a broad idea of what we will be doing today. We will build a ramp using two cardboard pieces like Komal is showing. The idea is that we will cut a shape like a, a quarter of a circle on the cardboard on two of those sheets, and then we will be assembling them parallel to each other in order to hold the ball in there.
So
So
I have a cardboard here, right? And these are these are two cardboards that I've assembled together, and here I have a ball.
the assembly of the two uh, sheets of cardboard is could be complicated depending on the ball, the size of the ball that you are using. It may be as big as a basketball, it may be as small as a marble. So you maybe need to um, adapt your design, your the way that you fix every piece together, and that is a very good engineering problem, to have a really nice structure for your ball to fall through. And in my case, I use a box, a really flat box, so I only had to cut a piece and then do the shapes on both sides, and I fixed some masking tape there to hold everything together. Kamala had to do a
I made a
different
bigger one.
strategy. And she used a cardboard in between the two sheets in order
Yeah.
to space them. But in the same way, you may have to worry about how you fix this ramp to your table in order to stay fixed as the ball is traveling, as the ball is doing its thing. So
Exactly.
it may be a really good challenge, a good starting challenge. The idea is that the ramp finishes almost horizontally. Okay, in that way, the ball will leave the ramp almost with no vertical velocity, only horizontal velocity. In that way, we can isolate that effect and analyze the falling of the ball independent on the traveling horizontally of the ball. So that's the idea, the general idea of the experiment.
There you go.
Yeah. So if you want, you can start figuring out with your materials, with the ball that you have at hand, how would you uh, build this ramp for you. It may be similar to the one that Kamal has, or similar to the one that I had here.
This
Turn
way.
it sideways like this.
Oh,
Okay.
that way. 90 degrees. There. There. Well, I can send you better pictures. Can send you better pictures for sure. So I use simple masking tape. So we want students to eh, come up with their own ideas, right? For example, I used masking tape and extra cardboard, and I cut the cardboard here, and I
Yeah.
actually have, I had, I have here my pieces. So I have, so I cut this. There you go. This is how I cut it. These are two pieces that I had. All right. There. Great. So,
So
Javier, what's the next
you
step?
can mark the cutout with a compass like this. That's a really simple tool in order to be more accurate when you're cutting the cardboard, and you can cut it with scissors or a cardboard cutter of some kind. When and students can do that also, trying to figure out the things that they have at hand and the things that they can do with the amount of cardboard and the materials that they have at home. So
Absolutely, absolutely.
let's keep going. Once
Fantastic.
that we have defined more or less our problem, we will be watching a ball fall through a ramp. And the question is not that simple, right? What can we do in order to understand how the ball will fall or where the ball will fall? So the in order to do that, we have prepared a simple exercise for you today. In a blank sheet, you can do like a cloud of variables. There are several that can be very interesting for this experiment. For example, the size of the ramp could be could affect where the ball lands, the shape, if the shape that we cut out may be uh, important or may not be, the color of the balls that you're using, the size of the ball, the mass of the balls,
Okay,
the
so
height of the
Javier,
table, etc.
you want us to draw in a piece of paper
Yeah,
all, or to write down all the variables involved in this process?
the ones that we think that could be important in this experiment. That's the
Okay.
idea.
For example,
They
the
may
height.
not be at the end, but that's okay.
Right. Okay. So we just have to write down, or in a piece of paper, we want to write down
Yes,
all the variables.
spread out,
Okay, let's do that.
not as a list, but spread out throughout the sheet.
Okay, so we want to spread out all in one sheet of paper. We want to spread out all the variables involved in this process. And in this one, right? The experiment that you described, right?
Yes,
So in this experiment, what are all the variables? And we're showing it in the screen. Like, what are all the variables involved here? So I'm gonna take a paper and pen here.
and if you want to share with us, you can share the variable that you think is the most important in the chat, the one that will be playing the bigger role in these experiments. Maybe gravity, maybe air density, maybe temperature, maybe ball size, ball color. Lisette suggests in the chat that we could use a pipe insulation cut in half. I'm not that familiar with pipe insulation, but I suppose that could be like a track, like a tube, a half of a tube, something like that. You may use that. The idea is not only that it falls, uh, it won't fall in the straight line. It should fall in this like smooth curve. So at the end of the track, it leaves the ramp almost horizontally, as horizontally as possible.
Okay, there I have a sheet with all the variables that I think are
So
involved in this.
Liselle is very aware of physics, and she's suggesting some variables like position, I think, velocity, acceleration, time, gravity. Martha adds vertical displacement, height to the bottom of the ramp, acceleration due to gravity, the time from leaving the ramp to hit the ground.
Like the difference of time from leaving ramp
Yeah,
to hit the
that
ground,
that
right?
period of time.
Perfect. Yeah. So what
There
are
may
all
be others. Every system may also affect the result. Of course. We're dealing with the real world, and it's very hard to remember because we are used to dealing in ideal worlds. Usually, when we teach physics, but when we experiment, we do it in the real world. So air could play a role in this experiment, and as air could play a role, it may be different to launch a tennis ball or a small rubber ball or a marble, a glass marble. So it may change our results, or a steel ball.
right?
So you have to take that into account when you do your cloud of variables. The next step for us today is to figure out which of those variables are connected by theory. You already know a lot about motion. We usually study kinematics in the school and university, and after that, so you may know that several of those variables are connected through theory, through some equation that you know. So connect them and see if anything is like neatly everything locked together, or if you have some things that are just floating around alone, not connected to anything.
Okay, so we have to take all the variables that we noted down and connect them.
Yeah, through
So,
lines.
okay, so for example, if
For
I
example,
I chose
for
height to
example, the sorry, Lisel suggested velocity and acceleration. If those can be connected through an equation from theory, then we drew a line between them. That's the idea.
so like
If Martha knows that acceleration and the height of the bottom of the ramp are connected through some equation, they may connect the two of them, and so on and so forth. So through this cloud, we will see just a big lump of things that we know, and some things that we may not know how they work. And that is the interesting part, because theory is good in theory, right?
yes, indeed. Theory is good in theory.
So
Absolutely.
David knows kinematics. He knows.
Absolutely. Okay, so I've connected some of my variables. I don't have as many variables as Martha and Lizelle wrote down, but I've connected some. So, well, what's next?
So what's next? Um, Now that we have a gruesome idea of what will happen in the experiment, we will have to do the experiment. We will
Absolutely.
You will have to build a ramp if you haven't yet. We will have a few minutes to do that. You can do some test launches in order to figure out where the ball will fall, where you're gonna put it, how you want to hold it, and take into account that the in the following steps we will be recording a video of the motion. So you will have to in one hand put the ball in the ramp and observe the motion of the ball, in the other hand record the movement. So those two things could be incompatible. I couldn't do it the both things at the same time. I asked for help, so you may need some help to record in the following minutes. So ask for a helping hand if you have someone at your house with you.
Yeah, it could be your kids, your significant other. In the case of the students, it could be their siblings or their parents.
And in experimenting we could involve the family, and that it's a very very good learning opportunity that we cannot let pass by, especially when families are stuck at home together. We could be doing things with them.
Okay, so I want to see who's building their ramps. There Martha is with her cardboard and is building a ramp.
Anyone else is building with
And there is
us?
Mokgaola. He's also building a ramp with some cardboard.
Cool, cool.
Hector is also building his ramp. Oh
Hector,
wow,
cool.
Hector, that's a good
That's a
wow.
very good ramp, yeah. That's a good
I
engineering
didn't
site.
expect that. I didn't expect that, Hector. That's fantastic.
That's
You did
cool.
that.
That's very cool.
Brilliant. Uh, okay.
Don't
David,
worry,
no
David.
worries, no
Follow
worries.
the explanation. we will leave, as you know, we are recording this on YouTube, so you can watch our webinar afterwards and maybe even show it to your student if that's any help.
Yeah.
So we will do
Awesome.
it. We will be waiting a few more minutes for you to test your RAMs. You see, this is not a very complicated system, and it's very simple, but could be very complex for some students to build. So you should ask them to take their time, to be aware of how the ramp will behave, especially if you have a very heavy ball. But besides that, it's a very simple system. Just two layers of cardboard parallel to each other that help us guide a ball.
Yeah, Hector has a very good helping hand there. Is she your daughter?
Yeah,
Yes.
cool. There's a future scientist in the making.
Yes. Brilliant, brilliant.
So
So
whenever
you
you're
already have the
ready,
ball there,
we will
the
start
rolling ball.
with the measurement part. That's always a standpoint where we should be very aware of where what students are doing and what problems they are having. We are reviewing a complex tool. Camera is one of our most complex tools, due to the number of steps that you have to do before you get the graphs of the motion. So once you review this webinar, it will be very natural, very comfortable, but the first time is always a little bit rough. It's always a little bit more difficult. So um
Great. So I see Hector has his ramp. Mokaola also, I think, has his ramp. Martha is still building her ramp. Oh, there she goes. I can see
now
it.
she's finishing right now, so
Yeah,
she's
she's
very
finishing
quick.
her ramp. Brilliant, brilliant.
Maybe we
Uh,
can move on and
yep,
start with the tool. You can hear us as you finish your ramp, because the camera tool, as we've been saying, is a very complex tool. So we will review them step by step.
perfect.
If you don't already, you need the our app Lab4Physics. You can download it from Google Play or App Store. And once you done that, if you don't have an account already, you can use for 24 hours the demo account that we share in the chat. So that may be necessary if you haven't already. When you do that, you will see all the tools unlocked and all the experiments available for the next 24 hours. So you can do a lot more experiments after this webinar.
Absolutely. And our team is in the chat if you need some help. The rest of the Lab for You team is in the chat to support you.
You can install Lab4Physics on a tablet, on a cell phone, and not on a computer, because it don't have all the sensors that we need to experiment. But you can use Lab4Physics in your device, your preferred device. So
Uh,
we will be using the camera that's in the tools section on the homepage of the app, and it has this big orange symbol. So once you press the camera symbol, you will enter the the home for the tool that shows two options: new measurement and save results. Since this is the first time that we do an experiment, we will be going through a new measurement. As you do that, your phone camera will open. If you haven't opened it before, it will ask you permission to use the camera. So give it permission, allow it to record a video, and the video tool will open and you can record a video of the motion. So the idea is that you place yourself almost perpendicular to the plane where the movement will occur. So um, That's the reason that you may need some help in order to do both things. Put the ramp on top of the table, prepare your camera, and record the motion. We have an motion example there, Kamal, so we can just play that video
Here.
for just for reference.
Yep. So there's a ball falling. There's
That's a
a
one-dimensional motion, but we can observe a two-dimensional image. So we will do a two-dimensional motion to apply more consistently this camera tool.
yeah. So Javier, here, just in this video, we can see that there's also a reference point, and there's uh there you go. Oops, sorry.
Yeah, we will use some information coming from the image. So we will use a reference distance, and we will for this experiment, I encourage you to use the distance between the top of the ramp and the floor.
Okay. So
Okay, we will measure that afterwards if you haven't already.
okay.
So we will pause our presentation so you have some time to put your ramp on top of the table, put the ball on motion, and record that so we can analyze it afterwards.
Okay, so the ramp should be on top of my table. So I have this ramp on top of my table. Okay. And the table in the corner, so that when I place the ball here, the ball should fall into the floor, onto the floor, correct?
Yes, we will record the motions from the moment that it exits your hand until it hits the floor for the first time. That's the
Okay.
motion that we're interested in.
Okay, so here's the helping hand aspect, right? So we need
Yes,
someone to record with Lab4Physics.
Hector, we have some helping hands in the chat that can help you unlock the camera tool. In order to do that, you have to uh, end your session and enter with the demo user that's in the chat. Okay, but a helping hand will guide you if you have any other trouble.
Awesome. Thank you. So Javier, once again, so
We have a ramp.
we have a ramp. I'm just gonna pause. Let me pause the share. Uh, Wait, let me stop the share here. So we have the ramp, right, on top of a table, and we let the ball roll. Correct?
Yes, that's the idea.
Perfect. So I know some of you have a helping hand. Who else has a helping hand there? There. And she's waving. Oh, fantastic.
So
There's a
record
helping hand.
the motion, and we will wait a couple of minutes so you can um, prepare the measurement and do everything that you need to for the next step. So don't worry, we will wait for you a couple of minutes, and we will show you what you have to do next.
Perfect.
So Martha is giving it a go. Mokola, are you okay? Are you well? Sure. So write us in the chat if you need anything, please. The same with all the other assistants that we don't see on camera right now, but we are very, very aware of you. Lisel, Loretta.
Perfect.
We
We need
we
to
the idea, Martha, is to record the whole motion from before you release it until it hits the floor. Bogola, don't worry about it. As soon as you have the needed equipment, you could reproduce this experiment and be aware of the 24-hour gap. So if you haven't downloaded Lab4Physics, please do. Please enter the demo user that we post in the chat so you can do the experiment as soon as you have your materials.
yeah.
From a
Javier,
side view, says Martha. Yes, from a side view.
should I,
We have a 2D motion. We need a 2D image of that motion.
Javier, should I put your video or the steps of the camera first?
Let's wait a couple of seconds so our assistants can capture their video, and we will explain broadly the next steps for the app.
Perfect. Perfect. Perfect.
These steps are very quick. You will see that this, once you understand the logic behind the parameters that the camera needs in order to interpret the video, you will see that it's very, very straightforward. It's very fast to analyze any video. And these falling motions just take a couple of seconds to record. So you can do a lot of recordings and a lot of things on the camera tool. So
Perfect.
okay, I think we are almost ready. Martha is having some trouble recording, but I think we are on. Let's
Great.
move on.
Let's move
Let's
on.
continue. So the once you have recorded a video and you are aware that this is a good video of the motion that you want to record, you will tap on use this video. Okay, and after you tap this, you will see the following screen. You will see a bar with two circles at each end and a box on top of the screen. And this is a reference length that we need to know in order to transform the pixels of the image into real world distances. So for example, if you know the distance from the top of the ramp to the floor, and that may be, I don't know, like 100 centimeters, then you will move the bar to the known distance to where you measure the distance for one circle on top of the ramp and one circle on the floor. And afterwards, you will enter the distance in the box on top of the screen. So that's the
So,
first step.
so
You
Javier,
probably you would need a measuring tape like Kamal is showing in order to measure a bigger distance that a ruler can measure. If you are taking that into account, you can also use a smaller distance if you like the height of the ramp. That can also be used as a known distance, or if you are in the frame, you maybe use your own height if you can identify your feet and your head in the video.
okay,
So you
so for
measure that
you,
in the real world, like Kamal is showing. Then you move the bar on the screen to match that measuring tape or ruler, and you enter the known distance on the box on top.
okay, so what Javier is saying here in the camera tool, where it says points and there's a space, you enter for for reference, you have to enter a reference length. So here, my reference length is actually 55 centimeters. So if these 55 centimeters are going to be in the video as they should, I have to enter this reference. And here, as you can see in the presentation, the two circles, one on the top and one on the bottom, are actually measuring that. So we first have to enter a reference length. Okay, so we have entered the reference length. So Hector, if you're running the experiment with us,
Oh, you are so far ahead of
oh,
us.
he's in step
We
number
will move
5.
ahead.
We're in
Don't
step
worry.
number 1, Hector. So
Let's go on then. If
okay,
everything is okay, let's move on.
okay. Then next,
Then you will see on the screen a reference system, an x-axis and a y-axis that you can move around and put wherever you want on the screen, on the image. So in order to do that, you have to um, move the center of the reference system, that is the green circle, and you can put it wherever you want. For example, at the top of the ramp, at the floor, at your feet, wherever you want.
So
This,
depending
go
on
ahead.
where I want the reference system, or depending on where I want my axis, X and Y, I position the axis.
Yes. And the idea is that there are some positions that will be more comfortable in order to do the analysis later. But if you don't have any idea of where that could be, then you can put it wherever you want. The analysis later will work no matter what. But if you have any prior knowledge of the system, you may choose a more significant reference system. But
Perfect.
it's on you. You can move it and put it wherever you want.
So the quadrant in the graph will depend where you put the axis system.
Yes, you
Perfect.
can have only negative uh, numbers or only positive numbers depending on where you put the reference system. And the last one is the more engaging part of the experience. You need to follow the object around on the video, and in order to do that, you have to identify more or less where the motion starts, where the interesting part of the motion starts. Or you will have to check every frame in order to identify where the ball is. If you don't want to do that, you can move using the bar at the bottom. You can move it around and see as if it were a video, where the ball leaves the hand and leave it there. That will be the starting point of the analysis. And in that frame, in that image, you can move the circle around and put it on top of the ball that will be following. um, and when you are absolutely sure where the ball is and you are capturing where the ball is, you need to tap the screen just once. That will mark the center point with a dot, like in the screen, like a green dot. And the image will change to the next image in the video, to the next frame in the video. And the ball will have moved to the next place. You will need to move again the circle and repeat, tapping the screen, marking where the ball is, and you will be following where the ball is. So how would this look on your cell phone? We record this from a tablet. So first you have here, after we record the video, we can review it. We can make sure that everything is okay. We will use this video. So we have the reference length that we have here, 100 centimeters from the top of the ramp to the floor. There it is, marked. We will click next. We now have our reference system. We can put it wherever we want. I chose where the ball leaves the ramp, right there. And finally, we move the circle to where the ball is. So first we make sure where the interesting part of the motion starts, where the video starts. We start tapping the screen, following the ball like that. And we enter a tricky situation because now that the ball is moving fast, it may be blurry and may be hard to follow. You have to choose where you want to follow. The center of the blur I mark in any case. You can mark the start or the last part of the blur, and after that you press next and you have the graphs. So that's as easy as PC.
Brilliant. That's fantastic. Thank you.
So if everything is okay, you should have graphs right now coming from the video that you analyzed just now.
Perfect.
So
Beautiful.
we have some questions for you at the end of this small experiment, because we measure some things that you may have listed at the beginning of the experiment. Some of the things um, that you listed may be related to some things that we can measure directly from the video. For example, if you listed potential energy, you can deduce potential energy from the vertical position of the ball. And you can check other variables that may be related. One of the variables that we could measure is the velocity in the instant where the ball leaves the ramp, and we can see that from the plot, from the velocity graph, and where the ball leaves the ramp. So that may be one of the variables that you can measure. So the idea, now that you have a ramp, that you have a ball, and that you can measure the motion of the ball using the camera tool, is how can we design an experiment that we can address if two variables are related. For example, how can we see if the drag of the air is related with the distance that the ball hits the ground from the ramp, right? So that could be one experiment that you could design. We don't have much time to share your ideas. This is an open question because it will depend on the circumstances that you have, on the materials that you have, and also on your particular inclinations. So it may be an open problem right now, but you can do it if you can measure, and we can using the camera tool, and if you can modify your setup um, in order to change the variables that you see fit.
Perfect.
So
And so the variables that we listed in the beginning, now we have to relate two variables of those.
we have to imagine how an experiment would be that could figure out if those two variables are in fact related. And
Exactly.
that is not a simple task. That entails creativity, evaluate, and discern a lot of different options. Creativity, of course, in order to solve a very complex problem. And those are all high level skills that we all know are very, very hard to develop and very hard to achieve.
Right. If we think of like Bloom's taxonomy, these are like higher level
The
skills.
highest, if you count create, the
Right.
highest one. So we are talking about a very, very endearing and very hard task. So it may take some trials, it may take some experimentation for your students, and if you want to place a big problem like this, it may teach them more things than just physics, more things like um, how science is done, how a very good experimental question is posed, how scientists face challenges like uncertainty that was mentioned before, or difficulties in the measurement, or the the obstacles that the tools themselves put in front of the results.
Absolutely. Absolutely. Great. Share your ideas in the chat if you have some ideas on how you could design an experiment that relates just two variables. We are reading the chat, and I know that we've got just few more minutes left. Javier, if you can briefly also talk to us a little bit about why are we doing all these experiments the way we're doing it.
Yes, because we know that this is a hard task to experiment at home. We are alone, more or less, without the teacher, without its assistance. But we know that through experimentation, we can actually develop high level skills, as we mentioned before, and 21st century skills like communication, creativity, and those skills are very needed in the workforce and very needed for an active citizenship. So those are the things that we want to accomplish with our students in a school. So in order to do that, we take a strategy that's very well known in the education, in the science education world. Let's call inquiry-based pedagogy, and it has some steps that we have transformed. But if you are aware of the NGSS system, are the same five steps that are shown in their programs, and they are a very good structure to engage students, to put them inside the experience, put them as a protagonist, and let them develop the skills that they need to do. And we do that by guiding the process with questions, with procedures, with um, with engaging real life situations that could motivate students to solve the problems that we are posing for them.
Absolutely.
And it's very important that we don't forget that even though we are in a very special situation right now with COVID and with isolation and with everything else going on in the world, education still goes on. Students still have to take advantage of the things that we are teaching them. So inquiry is a good way to accomplish that, to stimulate the students to develop self-awareness and autonomy, to learn from their own mistakes. We talk about the mistakes in the last Spanish podcast if you're interested in our podcast. Um, but it's very interesting, and you can as a teacher assess the process, assess what students are learning through the way that they expressing what they understand of the phenomena they are studying, and you can return the questions to them of how they want to solve problems and why they want to engage in this kind of um, situations, in this kind of experiences. So this could be a huge focus of one unit, of one arc of a subject, and it could be a highlight to really understand the topics that they are related to the real world, they are useful. And even though we teach them more the most of the time as dry and as difficult as they sound, they are not that hard and they can be observed practically in the real world. So inquiry help us with that. Is proven in the sense that a lot of people have studied it in a lot of circumstances, and it gets a positive results most of the time. And we are trying to improve that odds through our questions and through our experiments that we present to you. So
Absolutely.
come on.
Yeah, no, absolutely. And here, because we've just got 2 minutes left, Hector, I think Hector is suggesting as we asked everyone to put in the chat, what would they do with this experiment, and how are they feeling inspired or not with this experiment? And if they could answer the question that Javier has posed, how can we design an experiment that relates just two variables? There is one proposal by Hector. We know that these are challenging times. We know that many of you are either 100% distance learning, others are hybrid. Some are actually opening up. We just want to be with you in this time. Thank you so much for joining us today, and for being part of this webinar. We truly believe that the next Einstein or Marie Curie can be anywhere in the world. If you need anything, please let us know. These are our contact details, and we're happy to answer your questions. Thank you so much. I'm gonna end the YouTube transmission, and the ones who are staying in the Zoom call, you can stay for longer, as we will stay for a few more minutes. And yes, we will share the YouTube link with all of you as well. Thank you so much for joining us. See you next time.